Important. Hello, myself Suraj Gite. My roll number is 35. The topic of the DBMS that we are given for the presentation is transaction management, DBMS. Transaction management is a crucial for maintaining data consistently and integrating it. Transactions are the collections of operations. They are treated as a single unit of force. They ensure that data is updated correctly and prevent inconsistency. So transaction is basically the way where all the transactions are maintained properly from the creation to the disposal of the transactions. Let's firstly understand what is the transaction. Transaction is a sequence of operations that are executed as a single or individual unit. Each operation within a transaction is performed as it were a single step. If any operation fails, the entire transaction is rolled back and ensuring data is consistent. So there are four main types of transaction we can say. Uh, that is the first can be atomic transaction. Atomic transaction is either fully completed or not at all. It ensures that the all or nothing principles for the data changes. As we can take an example of a phone pay. There, if we get done any transaction, the amount would be fully deducted or transaction would be fully cancelled. Second is the consistent. A transaction brings the database from one consistent state to another consistent state. It maintains the integrity rules and constraints. If you done a transaction, there would be one consistent state. Either it would have the all amount in the sender's account or all amount in the receiver's account. Third is isolated state, where multiple transactions happen simultaneously, appears as they are executed one after another. This avoids interfering with each other. Let's say one account has getting a amount from the other five accounts, so there should not be overriding of the accounts, overriding of amount. So that's why the isolated data is provided. So third is a durable. So once transaction is successfully committed, the changes are permanently stored in the database. So even if the system crashes, the changes are preserved. So there should be a durability of the transaction. If the any transaction failed, if you don't have the backup of the transaction, there would be a big issue. So the next is asset properties of transactions, uh, where asset properties are the aim is atomicity, consistency, isolation, and durability. As we have seen in the last PPT, that are basically the durable asset property that are fundamental of transaction management. These properties ensure data integrity and reliability. That is given in this slide. Atomicity ensures that all proper within the transaction are treated as a single unit of work, ensuring that they are either completely or non consistency that would amount would be consistent in a sender's account or receiver's account. Third is isolation, where insulation ensures that the multiple transaction happen simultaneously. Fourth is the durability, where ensures that once a transaction is successfully committed, the changes are permanently stored in the database and they survive system failure. Next is transaction states and life cycles. So how the transaction is done, that is given in the slide. So transaction go through a well-defined life cycle. A transaction between the different state depending on this status and progress. This helps with while understanding the state of transaction and how it is handled within the system. So there may be four steps of this. The first can be the active state, where a transaction is currently executing operations and the transaction ongoing and is not yet committed. We are sending an amount. We are entered the pin, but the transaction is not done yet. So this state is active state. The second is partially committed. Transaction has completed all its operations and is ready to be committed. However, the changes are not yet persistent. We have entered the amount, needed the pin, but we have not sent the amount yet. So that state is the partially committed state. We have said like we can click the button, but the amount is not deducted from our bank. Third is a committed, where the transaction is successfully completed and all the changes are permanently saved in the database. Fourth is about a state the transaction are interrupted. The fourth state can be the where the transaction is failed from the receiver's or sender's account, and that would be deducted by the senders, but not yet received by the receiver. So this state is about this state, and this transaction would be cancelled. And the as we seen in the asset property, atomicity, like in the atomicity, all the steps are would be cancelled, and we the transaction would become at the first step. The next is the concurrency control in DBMS. So concurrency control ensures that a multiple transaction can access and modify data concurrently without compromising the data integrity. This involves various mechanisms to prevent data conflicts and inconsistency. So there are 2 to 3 main concurrency controls. The first can be locking. Locks are the used to control access data. Different types of locks, like shared and exclusive, are used to prevent conflicts operations. So second is timestamp ordering. Transactions are assigned timestamps, and the operations are ordered based on the timestamps. This prevents the conflicts operations and by ensuring that the operations are performed in the correct order. So third is multi-version concurrency control (MUCC). The MUCC maintains multiple versions of data, allowing the transaction is read and write data without blocking each other. So next is isolation level in the DBMS. So there would be many isolation levels defined. There is a degree between the concurrent transactions. Different isolation levels provided to various levels of protections against data consistency, balancing a performed and consistent. So there may be more isolation levels. So there are basically 4 main isolation levels. The first is read with uncommitted. This transaction can read uncommitted data, which are lead to dirty reads. uh, the second can be read committed data. A transaction can be read with the committed data, preventing a dirty reads, but allowing non-repeatable reads and phantom reads. So third is a repeatable read. A transaction can read a data multiple times and get the same values, preventing the dirty reads and non-repeatable reads, but allowing phantom reads. The fourth is a serializable reads, where the transactions are executed serially, as it is the were run one after the other, eliminating all the concurrency issues and ensuring the highest degree of isolation. So next is the dead blocks and how to handle them. So dead blocks occurs when 2 or more transactions are blocked, waiting for each other to release the resources, creating a circular dependencies. This prevents any of the transaction from making progress. So let's take an example where 2 people are sending amount to a single person. So there is a loop that works while we are sending an amount. If a 2 receivers sends amount at the same time, the system waits the after doing the first transaction is the first transaction done or the second transaction. But when the 2 transactions comes at once, the system waits for both the transactions to be done and where a deadlock comes. So there would be some steps to prevent the deadlock. First can be detection. Deadblocks can be detected using algorithms that analyzes the current state lags by held by transactions. The second can be prevention. Deadlock can be prevented by using techniques like lock ordering or timeout mechanism to break a potential deadlocks. The third can be resolutions, where the once a deadlock is detected, 1 or more transactions are chosen to be ruled and back releasing resources allowing their transactions to be proceed. So as we can see in this image, there is a Alice and Bob. They have the databases post details and post. They have the IDs. He has begun the transaction, but Alice begin the transaction, where Bob's also begins the transaction. So as he has done the transaction, it will update the post details. Uh, then he will update the post details. Post details both are updated and both have the same IDs. So as both have the same IDs, there will be a loop between them. The Bob's will post will wait for the proceed for the reveal and updates post will be done. So there are two-phase commit protocol. The two-phase commit protocol or 2PC protocol is used to ensure that it is a distributed transaction is committed is or aborted automatically across the multiple transaction databases. So there are 2 phases as it has a name. Phase 1 can be preparation phase, where the coordinator sends a prepare message to all the participants. If participants can commit, it is respond with yes. Uh, if it cannot commit, it respond with a no. Phase 2 is commit or abort. Based on the response from the participants, the coordinator either commit or abort the transaction. If all the transactions respond with yes, the coordinator sends a commit message to all the participants. If the participant respond with no, or if the coordinator receives a timeout, the coordinator sends an abort message to all the participants. So as we are given this diagram here, there will be about a commit or about message given to the client. If all the transactions would be yes, this will provide the message yes, or this will provide message no. So there can be a distributed transaction management. Distributed transaction management involves a coordinating transaction across multiple nodes or databases in the distributed system. This requires a mechanism to maintain consistency and atomicity in the distributed environment. So data distribution data is spread across multiple nodes, making it more difficult to manage transactions across the different locations. So second can be consistency. Consistency. Maintaining data consistency across the multiple nodes is critical in distributed environment. So third is a communication. With reliable communication channels are essential for coordinating transaction, ensuring data integrity. So fourth is a time synchronization, where accurate time synchronization is important, that ensuring the transaction happens in the correct order. So at the conclusion, we can say transaction management is essential for maintaining data integrity and consistency. By understanding asset properties, transaction states, concurrency control mechanism, and the distributed transaction management, developers can build robust and reliable database applications. So thank you. Myself Suraj Gite, role number 35.